Hello there, everyone. Today I'm going to analyze an observation made by Dave Marsh and a friend of him. Dave Marsh is in UK and his friend in Tasmania, southeast of Australia. This is the place, Tasmania. And according to his locations or the coordinates that he gave me, the locations in UK is Ripley, and in Tasmania is probably near a town called Ulverstone. So the observation or the experiment was to measure the elevation angle and the azimuth of the moon at the same time from both locations. And here is the outcome. The elevation angle for Dave was 8 degrees and azimuth of 66. In Ulverstone, it was 22 elevation and 314 of azimuth. So I had to check these numbers against mooncalculator.org, and I found that the elevation angle of 8 in that day, 17 November, as he provided the information to me, was around 2025. So that's good. Now I can add 11 hours and get the angles for Tasmania, just to confirm the integrity of these numbers, because it's usually hard and inaccurate to use the TDLOT app on phones. So these were my findings, that when the elevation angle was 8, that was 825, but the azimuth was 70. And for Ulverstone, Tasmania, at that time, 11 hours ahead of the UK, I mean that's 7 a.m. there, the elevation was 15 and the azimuth was 313. So I had a hypothesis that if both locations are measuring the azimuth of the moon, then the direction from the first location to the second location is on the great circle, this great circle here. So my hypothesis was that to get the great circle from Ripley, UK, just draw that circle here and get that angle. So let's get that angle here. It's 74.5 from Ripley, UK, towards Tasmania or Ulverstone. Okay, let's see from Ulverstone what's the angle. Because I believe that angle from Ripley to Ulverstone is going to be the azimuth of the moon, if both locations are measuring the moon azimuth from the same point at the same time. So remember that from Ripley it was 74, and here from Tasmania is around 309 degrees. So let's go to mooncalc.org and see what does it have to say about this. So this is Ripley. I moved the slider until the moon azimuth was 74, same as the direction of the great circle from Ripley to Tasmania. And the time was 20:46, that's 8:46 p.m. That means we're going to be looking at 7:46 a.m. in Tasmania. And we're going to check the azimuth there. So here is Tasmania. So Tasmania, 18 November, that's the next day, 7 a.m. 46, and the azimuth is 309. Well, I think that could be something that supports the globe, and we can never get this observation on the EAE map or the Flat Earth map. Was that enough for me? No, that was not enough. I wanted to do more. So I took an image of my globe model here, and I marked UK and Tasmania, and of course, this is very delicate. I could go off by 200 kilometers if I wasn't very careful. And then I connected from the center of the Earth, or the circle. You see this yellow circle? I made this circle just to know where's the center of it, and I measured the angle from here to here, and from here to here. And as you see, the angle here is off between the line and the toothpick. Originally, my idea was to use the toothpick as the vertical and measure the angle from it, but it was a failure. So I did this idea, and this line measures 115.8 from this black line, and this measures 37. So now that I knew the vertical, I drew the horizontal, and then I put the elevation angles of the moon. And that's back to the Excel sheet here. The inverted elevation, I don't know what to call this angle. Dr. Zach or Decimal Z call it the angle of deceptions. So this was 97, this is 78. The reference is 115.8, and for this, for Tasmania was 37. These are the angles of the horizon. This angle from the east of this image. And the relative elevation, that's the actual angle for each line of the moon. These white lines here, these are the direction of the moon if this is the Earth. So they are not parallel. There's 4.4 degrees between them, but let's not remember that there's around 12,000 kilometers between the 2 points. I didn't calculate that, just roughly estimation, because they are across, the opposite sides of the Earth. So I just tried 12,000 kilometer against the 367,000 kilometer of the moon distance. That gave me a parallax of 1.8 degrees. So there's an error of 2.5 degrees between my calculations and the globe. Let me explain what does that mean. That means that these lines, they should not be parallel because the moon is not that far. They should be converging with an angle of this 1.8 degrees. But there's excess of 2.5 degrees. They're converging more steeper than they should by 2.5 degrees. Now, if someone can do this experiment more accurately than me, that would be great. But I think 2 degrees, when you work with something that is 15 centimeter wide, and this is not educational globe, just for decoration. So I think being off by 2.5 degrees is wonderful. And just to make things clear here, this was a great circle. As you can see, I put a rubber band around my globe. It's exactly in the middle, so it's a great circle. And there's a video here that I will play. So here's the video just to show that I put the location on Tasmania, or as close as I could, regarding the size of this globe model, and the location of the UK, or Ripley. And you can see the rubber band is cutting the ball in two halves. That's a great circle. So, what's the conclusion? The conclusion is that you can select point A and point B on Earth, one in the northern hemisphere, the other in the southern hemisphere, and you connect the great circle between them. Take the azimuth from the first point and go to mooncalc.org or suncalc.org and move the slider until you get the moon at that angle of that great circle. Check the time and take that time and go to the other location and move the slider until you see that time. You'll find that the moon or sun azimuth is the same as on the great circle from that second location to the first location. I hope that's not too complicated, or I hope I didn't make it complicated. It's real simple. Thank you all for watching.